We are discussing the 2023 ISI BStat paper, and this is the second question. Define a polynomial fx by fx as a determinant of 1xx, x1x and xx1 for x being a real number where the right hand side is a determinant. The roots of fx are of the form what? So we have to basically find the roots of this. So the determinant 1xx, x1x, xx1, this can be solved like this. So first what we do is we take the first column and we multiply this with x. So we multiply column 1 with x, and from that we subtract column 2 and we put that in column 2, and we multiply column 1 with x, we subtract column 3 and we put that in column 3. So if we do that, we get x into 1, which is x minus x will be 0. So first column remains the same, 1xx. The second column becomes x into 1 minus x, which is 0. X into x, which is x square minus 1, and x into x, x square minus x. And the third column becomes x into 1, x minus x, 0. X into x, x square minus x, and x into x, x square minus 1. So this is a very simple determinant which can be easily solved by taking the cofactor matrix of the first element 1 and expanding it using the first row. So the other two elements of the first row are zeros, so we just need the first element. So therefore the value of this will be x square minus 1 whole square minus x square minus x whole square. So this is x plus 1 whole square times x minus 1 whole square minus x square times x minus 1 whole square, which is x minus 1 whole square as a common term times x plus 1 whole square minus x square, which is x minus 1 whole square times 2x plus 1. So therefore the roots of this equation will be given by x equal to 1, 1 and minus half. Now if you look at the options given, the first option says the roots are of the form alpha, beta plus minus I gamma, which means that 1 real root, 2 imaginary roots, so this is not the case. Second one says alpha, alpha, beta, where alpha, beta are real numbers, which is what we got. So option B is the correct answer. I marked it option. Option B is the correct answer. The other options are alpha, beta, gamma, where alpha, beta, gamma are real numbers, but then this will be 3 distinct roots, whereas we have 2 equal roots and 1 unequal root. So option D says alpha, 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 which means all 3 roots are equal, which is also not the case. So option B is the correct answer. Now we go to the next question, which is question number 3, which says let S be the set of all those real numbers x for which the identity this is valid and the quantities on both sides are finite. Then what is the element, or what are the elements of the set S? So if I put x equal to 2k pi, that means if I put even multiples of pi, then I would get cos of x will be equal to 1. So So therefore the left hand side will be equal to sum of 1 to the power n, where n goes from 2 to infinity. So this is a diverging series. Similarly, if I put x equal to 2k plus 1 into pi, which means odd multiples of pi, then cos x will be negative 1 and the left hand side will become the sum of n equal to 2 to infinity minus 1 to the power n. Again, this is a diverging series. So therefore x cannot be equal to a multiple of pi. So x cannot be equal to n pi, where n is an integer. So therefore x cannot be any multiple of pi. So if that is the case, then we can see that the left hand side will be cos square x plus cos cube x, etc. up to infinite terms. So this is an infinite GP series where the first term is cos square x and the common difference is cos x. So the sum of this GP series is cos square x by 1 minus cos x. Now I can multiply the numerator denominator of this by 1 plus cos x. So I get 1 plus cos x times cos square x by 1 plus cos x times 1 minus cos x. So which can be simplified to give us 1 plus cos x times cos square x by 1 minus cos square x, which is 1 plus cos x times cos square x by sin square x, which is 1 plus cos x times cot square x. So this is the value that we get if x is not equal to n pi. So therefore the answer to this is option B. So the left hand side becomes equal to the right hand side if x is not equal to n pi.